Hello everyone, I'm Chenglong from Microsoft Research. Today I'm going to share you with our work called Data Formulator. It is an AI-powered concept-driven visualization authoring tool. This is a work together with my colleague Wang and Bongshin. Nowadays, data visualization tools require tidy data. And when the data is tidy, creating visualization can be easy. In this case, we have a data set of Seattle-Atlanta temperature in 2020. And if we want to create a scatter plot to visualize the temperature trend over time, what we can do is by simply mapping the date column to x-axis, temperature column to y-axis, and city to color, and then we get a scatter plot. This is so easy because our input data is in the right format for our visualization goal. However, when our data is not in a tidy format, creating visualization can be challenging. In this case, we have the same data set, but now we want to create a histogram to show the distribution of the number of days which city is warmer. As you can see in this case, what we want is to put a column called warmer in x-axis and put a count on y-axis and put warmer again on the color. But as you can see, the input data does not contain those required columns. And in this case, we actually need data transformation. In this case, we first need to pivot the table so that Seattle and Atlanta are columns in the output. And then we can compute a new column called warmer by comparing Seattle and Atlanta temperature. After this transformation, the visualization is easy again. We can map warmer to x-axis, map a count function to y-axis. This is a function that can be available in many visualization tools. And then map warmer on color. As you can see, in this case, visualization is easy because our transformed data is a tidy data for our visualization objective. But of course, this output is tidy because we did the data transformation. In practice, data transformation is not an easy task. The author first need to learn how to transform data, and more importantly, when to apply them. And then secondly, even if you know how to transform data, you actually need to implement transformations using either programming libraries or transformation tools. This requires your expertise as well as taking time to complete the task. Finally, data transformation is not a one-time task. Whenever your visualization goal change, it may require new data shape and you need to redo data transformations. This can be problematic in exploratory setting. So the question is, how can we lower the data transformation barrier so that people without much experience can still create a visualization? And how can we free people from the swamp of data transformation? To solve this problem, we designed a tool called Data Formulator. It is an AI-powered concept-driven visualization authoring tool. Instead of programming, the user starts by defining new data concept by providing example values or providing a natural language description. In this case, the user creates a new concept called is hot by describing that how it should be computed from temperature column. Then with the user specification, Data Formulator calls a program synthesizer or a large language model to synthesize data transformation to find a program that matches user specification. And this program is later used to transform the input data to obtain tidy data for the visualization purpose. And with the new transformed data, the user is able to create visualization by mapping new data concepts into visualization channels. This is the same as people's experience in existing tools. Our design considers the following. First, we choose to use multimodal specification to balance the ease of specification and system reliability. For example, program by example is really good for specifying data reshaping operators, and programming in natural language is really good for specifying computations. And the role of program synthesizer and large language model is to automate code generation so that users don't have to learn how to code. And finally, we give a similarity interface of using drag and drop to create a visualization, which is their familiar experience with the existing visualization tool. Now let's have my colleague John to give you a demo of Data Formulator.
Thanks, Chenglong. Data Formulator is a concept-driven visualization authoring tool with AI-powered support for data transformations. The data view shows your original and AI-generated data tables in our workflow. You can create or derive new data concepts from your original data with the help of an AI agent. Then, in the chart builder, you create charts by encoding data concepts to chart properties. And you can keep track of all your generated charts in the visualization view. To demonstrate Data Formulator, we'll start with this daily temperature dataset already loaded. The dates include all the days in 2020, cities are Seattle and Atlanta, and the temperature is in Fahrenheit for the respective city. This is a long or tidy form dataset. Let's get started by visualizing this data. When all data concepts are known, we drag and drop them onto chart properties and immediately see our chart. This scatter plot shows temperature for both cities over time. Now let's save this chart for a reference. And instead of temporal trends, I want to directly compare Seattle and Atlanta temperatures. But we don't have these concepts, so we create new unknown concepts for Seattle and provide examples from the table. We then select example values for this new Seattle data concept. And then we do the same for the new Atlanta temperature concept. These examples provide the system with an understanding of the new data table we are trying to generate. We then drag and drop Seattle and Atlanta temp concepts to visualize them. Formulating generates a new data table from unknown concepts. Data Formulator is trying to construct this new table, but needs us to fill in the example table based on our original dataset. In the new data table, each row is for a day. The formulated scatter plot of Seattle versus Atlanta temperatures appears, and the formulated data table in the data view. The table is now in a wide format, and we'll just save this chart for later. With the data in this wide format, we can make some direct comparisons. So we derive a concept from Seattle and Atlanta temperatures to compute the difference between the cities. We describe the transformation and click to generate candidates. The first choice candidate appears with example difference values. We can verify the transformation's correctness as type script code, and we can also derive which city is warmer on each day. And we can verify them further. As in this case, Data Formulator has generated two candidate options. I like the verbosity of candidate 2, so we'll go with this one. Now, let's visualize these derived concepts of which city is warmer. I'll show warmer as color on the existing scatter plot. The colors are bisected as we'd expect. I want to show these patterns temporally, so I encode date on the x-axis and difference on the y-axis, and we see which city is warmer and by what magnitude using a bar chart. Also, it'd be interesting to know how many days is one city warmer than the other, so I'll create a histogram of that. And we see Atlanta has about 300 days when it's warmer than Seattle's 50. Finally, we want to show Seattle's temperature changes for the year. To smooth out outliers, we derive a 7-day moving average. And we're generated with two candidate options. Inspecting these options of derived values in code, both look to be computing moving averages, but the window is always right aligned computing the average for the last 7 days. Instead, we want to compute a middle aligned average. So we add to our description starting with 3 days before, ending with 3 days after. And we recompute. And and checking candidate options. Now the first candidate is actually incorrect, but our second candidate computes the middle line moving average that we wanted. We confirm and save this derived concept, and we can check the 7-day moving average in a histogram. There don't really seem to be any erroneous values, so we move on to create a line chart with date on the x-axis and the temperature as 7-day moving average on the y-axis. We can see that on average, Seattle doesn't deviate outside of mild temperatures throughout the year. Finally, we can recap all the charts we created in Data Formulator in the Gallup review. And now back to Chenglong, who will focus on the technical details and user study that we conducted.
Now let's dive into how Data Formulator works. Let's first look at how Data Formulator resolves custom concepts using programming by example technique. As you can see, given the input data, the user defines 2 custom concepts and then show how they should be visualized. And based on this specification, the system will first suggest and prefill an example output, T out, and which require user to complete. And this example output actually reveals the relation of custom concept, which will be used for the program synthesizer to synthesize the transformation program. And then given the input data T in and T out, the synthesizer will try to find a program P such that the output of the P will contain the example output T out. And to solve this problem, Data Formulator applies a enumerative search algorithm with pruning. It's essentially searching for the composition of data reshaping programs to find one that satisfies the objective. And in this case, the program is a pivot wider. And when we get this program, we basically apply this program to the input data to obtain the desired output, which will be the tidy data for the visualization purpose. Now let's look at how Data Formulator create derived concept. Given the input data T in, the user first select which data columns the new concept should be derived from, and then provide a description of how the transformation should be done. Given this specification, Data Formulator prepares a program sketch that contains input parameter, their type, and the output parameter, as well as providing the natural language instruction as part of the comment. And then Data Formulator asks for a codex or GPT 3.5 model to complete the program sketch, which will then generate a program that will be able to apply to transform existing columns into the new data concept. And then with the new data concept, this data is tidy and ready for visualization again. To understand how Data Formulator works with people, we conduct a chart reproduction study. We recruit 10 participants from Microsoft, including data scientists and applied scientists. We include 6 tasks and 2 data sets, try to cover all key tool designs. Each study session is 2 hours, an hour of tutorial, and an hour of tasks. We record the time for people to complete. We ask them to think out loud and use that to collect qualitative feedbacks and have a questionnaire ask them to fill out afterwards. Here are our 6 tasks, including 3 tasks related to the COVID-19 reports that shows the trend by year, and a smooth trend. Another data set is Seattle and Atlanta temperature we showed earlier, including direct comparison of temperature required pivoting, showing the distribution of the temperature difference, as well as the number of days is warmer as histogram. From our study, we first learned that participants are overall positive about their experience with Data Formulator. In particular, natural language works really well for deriving new data concept. It's easy to learn and pretty reliable. Participants were mentioning that generative code and example tables are very helpful for them to check in the result from AI agent, which helps them to verify the result and gain trust. On the other hand, using example to create custom concept can be challenging. They need to learn how to create examples, and also the process seems a little bit more black box to them. Finally, participants actually learn to trust the tool over time as the tool are generating correct transformations over time, but sometimes maybe too much, as they will be not as careful to do verification later on. So this is Data Formulator. It is an AI-powered concept-driven visualization authoring tool aimed to reduce people's effort on data transformation so that they can create visualization much easier. Thank you, and we would like to get your feedback.